So let's say you work for the bank and one day they come down to your office and tell you that they've been getting a concerning amount of fraudulent transactions and they need you to create a neural net that'll figure out any fraudulent transactions before they go through. They give you all the data, all the transactions for the last month, and they're on their way. Maybe around 100,000 total transactions and there are 500 fraudulent transactions. The first thing you do is take all the data they give you and throw it into a machine learning neural net and let it spit out a program that'll solve the bank's problem. But when the program is finished, you're being told that there are almost no fraudulent transactions in the data provided, which can't make sense. You know there's at least 500 transactions. The fundamental part forgotten in this process is that there were far more cases of legitimate transactions rather than fraudulent transactions, giving us an imbalanced data set. Hi, my name is Ushin Connolly and I'll be taking you through the importance of balancing data for your neural net and remedying imbalanced data. Imbalanced data is frequently seen across many fields of data collection and is a constant nuisance. Imbalanced data is when you have far more samples of one data type over the others being used. We saw earlier severe imbalance with only 0.5% of all samples being fraudulent. The problem seen when using imbalanced data for machine learning is that the neural net will skew towards the outcome with the most samples. By giving the neural net far more samples of one class over another, it never learns what makes these different and just assumes that most things fit into the larger class, which won't give you an accurate reading at all. This problem applies when separating input data and test data too. If the data being tested in balance, your accuracy result you end up with can't be trusted, as again it's going to skew towards the class with the most samples. Of course, this isn't an unsolvable problem. There are a few different approaches you can take, such as manipulating the data you have. Taking the fraud detection example we used earlier, we could instead undersample the data. In other words, to achieve a 50-50 split between data. So we would take all 500 of our fraudulent transactions and then take a sample of 500 legitimate transactions with an equal amount of samples for both fraudulent and legitimate transactions. With this, the neural net will learn to distinguish between the two types, which could give you a far more accurate reading. Of course, there's a glaring issue here, is that we've lost a considerable amount of data. We started with 100,000 samples, yet are now training our neural net with 1,000 samples, 1% of our total amount. More data is far better for accuracy, so maybe another route to go is to oversample. Oversampling requires us to get even more data from the data provided. A simple method in doing this would be to copy and paste the fraudulent data we do have and make it balanced with the legitimate data. So let's say we have our 500 and we copy and paste it 20 times, now we're ended up with 10,000. So now we have 10,000 fraudulent examples and we just, again, will undersample the data we do have and make that 10,000. Now we have 20,000 results. This of course introduces far more problems, as now we get into overtraining, which will make it so that very little data will ever actually be considered fraudulent, as there is an extremely heavy bias for the 500 samples given that have just been repeated over and over. Instead of this, you could instead try out synthetic data generation. This would create data that is similar to the data provided, but slightly different. A simpler solution to the lack of data provided is just to collect more data, which of course is far easier said than done. For the fraud detection, you could go back upstairs and say, I need more than just a month worth of fraudulent transactions. I need at least a year, maybe even years worth of transactions. 20 months worth of fraudulent transactions will give you 10,000 samples, which leaves you far better off than where you were initially. But sometimes this option of course isn't available. If the bankers upstairs say they can't give this to you, you very well couldn't start making more examples yourself, or you might find yourself in a spot of bother. There are many ways to solve imbalanced data in neural nets. Perhaps instead you want to penalise your neural net for getting the minority classes wrong, or use completely different algorithms or training methods. But the main takeaway of this video should be about highlighting just how important it is to have balanced data. Because another way of framing this example is with a cancer detection neural net, where trending towards the healthy instead of sick can cause some lasting damage.